Our first speaker is Emily Carter. She has been introduced yesterday, and let me just give a quick introduction about Emily. Emily is the founding director of the Center for Energy and Environmental Studies. Center for Energy and Environment. She is a professor in mechanical and aerospace engineering. By training a chemist, she got her undergraduate degree at UC Berkeley, her PhD at Caltech. For 16 years after getting her PhD, she was on the chemistry faculty at UCLA, and later also on material science and engineering, and then she joined Princeton in mechanical and aerospace engineering. Emily has more awards than I could memorize, but she is a member of the three major academies, the American Academy of Science, Arts and Sciences, the National Academy of Sciences, and the National Academy of Engineering. Emily is going to talk now a little bit about an overview of the Center for Energy and Environment, and we'll have questions later. One thing I want to ask all of you, and I'll remind you later, when you have questions, please state your name and affiliation before asking your question. Thank you, Emily.
Thank you. Well, it's great to see all of you here today, the second day of this symposium that is inaugurating, as Peter said, the Andlinger Center for Energy and Environment and Mader Hall. And I thought that it would be good because at the start or near the start of the symposium to give an overview of both the activities of the center, the people involved in the center, and that's what this talk is about. So there's not a lot of science except kind of an overview, but the rest of the day is about science and engineering and policy. And as you see from this first slide, essentially, the mission of the center is to do everything we can, and that includes both technology solutions and policy solutions associated with ensuring our environmental future, our energy and environmental future. And that really, it's clear to everyone here at Princeton that isn't the domain simply of engineering. It isn't the domain simply of scientists. It's not the domain only of people who are experts in policy, but really the best work will come and the most impactful work will come when all of these different groups in science, engineering, architecture, policy, economics, and even and maybe more especially human behavior will work together to find a portfolio of solutions. And speaking of the portfolio of solutions, I like to think about the way in which we start to articulate the problem of the solutions that we need to work on in terms of a timeline. We heard yesterday a lovely talk from Dr. Ellen Williams from ARPA-E about the portfolio of short-term projects that they are accelerating within the Department of Energy. And I was also delighted to hear yesterday the mention of the Rising Above the Gathering Storm report, which was a key report which led to the development, the proposal to establish ARPA-E. And we will be hearing this afternoon from the main author of that report, namely Norm Augustine. And so I urge you to come to that talk this afternoon, the former CEO of Lockheed Martin, who feels very strongly about the need to invest in energy research and development and how important that is in terms of the issues we heard yesterday from Ralph Cicerone, President of the National Academy of Sciences, renowned atmospheric scientist, about all the lines of evidence, empirical evidence for climate change and the fact that fossil fuel burning is a huge component of what is causing that. And so a huge part of the effort that we need to make, we both in the center here, Princeton at large, and in universities and government labs and industrial labs around the world, and among government leaders, is to think about this portfolio of solutions and how we can enact them over time. And so, as in fact Ralph Cicerone made the point yesterday, that energy efficiency is something that we could do right now. And so in fact, my view of the solutions has as a very first box that there's many things we can do in terms of energy efficiency that we should be doing in this country that we're not doing yet, and certainly around the world to help other countries. There are many countries that are doing much better than we are, but there are lots of other countries that don't have the resources that the United States has, where we could be helpful in terms of deploying energy efficient solutions. Obviously, I mean, one of the things that has really made a difference in the United States in terms of reducing carbon emissions has been the displacement of coal by having this abundance of natural gas. And the issue there is really to make sure it's done responsibly and cleanly. And so that's something that can, much of the technology exists already to make sure that that happens. There's policy issues at the state level that need to be resolved to make sure that happens in a sustainable way. And then, of course, the use of electric vehicles, which in principle, could, if you had a network of them, provide some storage on the grid, et cetera. So that's, near-term solutions. Farther out are, having fuel flexible and durable fuel cells. Right now we do have fuel cells, but, the fuel flexibility and the durability are the two issues that need to be worked on. Obviously we have solar and wind power, but having it cheaper and more efficient is a goal that's extremely important. Safer nuclear power, again, lots of things lots of issues associated with that, where safer also refers to the connection between nuclear power and nuclear weapons, and as well as, of course, nuclear waste and smart grid. Again, a lot of these things are close, but require both input in terms of policy and technology. Further out are, storage for the grid. Really cheap, effective storage for the grid is something that has to happen in order for renewables such as wind and solar, which are intermittent sources of electricity, for them to take hold. And then biofuels, notice here there's the word corn does not appear. So the idea is, I feel very strongly that we should be working on biofuels that come from non-food sources. And then CO2 capture and sequestration is out here. It's extremely important, and there's avenues that are being looked at, but there are no, there's no one solution yet. There are some demonstrations going on. There's been some announcements, even recently, from one of our partners, ExxonMobil, working with fuel cell energy, about some interesting ideas of combining fuel cells along at power plants to do CO2 capture and then use that actually to generate more electricity through a fuel cell. And so there's lots of innovation that needs to happen in this space. Why do we need this? Because we're going to be using fossil fuels for many decades to come. There's no way around it. Fossil fuels are wonderful, energy-dense sources of basically our quality of life. And that's not going to end for a long time. So we have to find ways to capture the CO2 and that don't have a huge energy penalty, which right now almost every, the conventional method does have a very large energy penalty associated with it. So that's, again, research and development that needs to be done. Further out are what I call solar fuels, which wouldn't necessarily have to be from the sun, but basically renewable electricity that then can drive some chemical reaction that can essentially run combustion backwards. So CO2 and water plus energy going back to the fuel. When we burn the fuel, we have the fuel releasing energy and then producing CO2 and water and oftentimes other byproducts that we don't like. But if we can then run the combustion process backwards with an input of electricity, either from a photovoltaic or from a photoelectrocatalyst or from nuclear energy or some zero carbon source, wind energy, then What's needed here is the magic bullet, the magic electrocatalyst or photoelectrocatalyst, and it doesn't exist yet today. So, so that's further out to get all of that right and optimized and cheap enough. That's key, cheap enough to compete with fossil fuels today. And the only way that's likely to happen is if there is a carbon tax. So that's going to come up in terms of policy, or possibly a robust cap and trade system. Waste heat recovery, if you look at the entire energy system, basically we waste over half of the energy as heat. And so to be able to find ways to collect that, and there are existing technologies that allow us to do that to some degree, but there's a lot more that can be done to be able to use that waste heat and again make everything much more efficient. I have it way out here because I'm thinking about technologies such as thermoelectrics, which are really for right now only have very specialized applications, and there's a lot more that needs to be done there. Superconducting electricity transmission, that actually came up recently, yesterday as well. The idea that we could make it so that we could have ambient temperature, so room temperature, superconducting cables. Okay, we're not there yet, and certainly not at the level of being able to have wires that we can, essentially have the electricity go through them, flow through them with no loss due to resistance losses along the way. So that's a long way out, part of the dream. And finally, and could be that we'll reach this before we reach this one, is fusion power. And I believe that someday the world will use as its base load to a large extent fusion power if we can manage to overcome the issues of how we control the fusion plasma and how we develop the materials that can actually withstand essentially being exposed to a miniature sun, right? Not a trivial problem by any means. And it's a beautiful physics and engineering problem, a material science problem. There's so many interesting issues there. And it's way out here, partially because of the challenge, which is much harder than going, and in addition, the lack of investment that's been going on for many decades. So, that's a choice. That comes up in terms of policy issues. So you notice I've completely hedged my bets here. There's no numbers on this timeline. And that's because a lot of that depends on policy, depends on what the incentives are in terms of course, also in terms of just random breakthroughs. That's why I like the concept of ARPA-E in many ways follows this kind of large portfolio of solutions, which is incredibly important. And what's also very important is you don't place all your bets on one idea. That's really important. And so we don't know where the breakthroughs are going to come from, and that's why there's no numbers on the timeline. In addition, energy and water are absolutely intertwined, and there's a million examples of that. And so one has to think about water resource development and management. This is an area that civil and environmental engineering, Peter Jaffe, who's the chair of our session this morning, associate director for research in the Andlinger Center, is heavily involved in as well. Climate adaptation, we heard yesterday, we talked about that with President Cicerone's talk about climate change and the fact that there's a lot baked into the system already in terms of how much CO2 is in the atmosphere and other greenhouse gases. And so all the way along this timeline, we're going to have to be working on issues of climate adaptation. We have work going on in the center associated with that. And environmental pollutant detection and remediation. Lots of work on sensors that go on in the School of Engineering and the Andlinger Center and in specialized centers as well. And then remediation, again, Peter Jaffe is an expert in that area in terms of pollutants. All of this is going to need to be going on at the same time as we're working on these solutions. And then, as I said, policy has a huge role to play. Human behavior, how do we get people to accept new technologies? The best would be is if we can have them accept these new technologies without it really affecting their quality of life. We don't want them to do it because they feel they have to sacrifice. So there's lots of issues there. And of course, the economics, none of these things are going to come into play unless they can compete in the marketplace. So it's a real holistic view that needs to be taken, be thinking about these things. And you might be wondering why there's orange boxes. The orange boxes are representing essentially the areas of strength here at Princeton, or that we have strategically hired in these areas in order to address what we think are the highest impact areas to pursue. Okay, so let me keep going here. I want to then go from that very high-level picture of the whole energy and environmental landscape and how we have to think about this over many, many decades and think about what the center can do. So you've already seen this mission statement on the first slide. And out of that mission, we came up with a set of goals. What can the center do that individuals here can't do by themselves? And so one is very important, to really create an intellectual community. And this symposium is part of that. So we have various ways in which we do that. I'll talk about that going forward. We also have funds through the generosity of many donors, including Gary Andlinger and others, to accelerate innovative multidisciplinary research. So basically to act as a catalyst for new research ideas, high risk, high payoff ideas. The next thing, of course, we're at Princeton. We believe that there's a huge role of the university, and in particular at Princeton, to not just train a set of experts, but to train people that will lead the field. So training the next generation of leaders. This is something that I feel especially is important with respect to the area of energy and the environment, because of cheap oil, we lost a generation of leaders for about 30 years. There was people working in the area, but at a very low level because the investment wasn't there on the part of national policy. And so we have the opportunity to really contribute to training many generations of leaders going forward. Also, it's extremely important, and this was part of Gary Andlinger's vision, to make sure that we don't just act as an ivory tower, that we do recognize that the discoveries that come out of the work in the center will, in fact, be translated out in a practical sense, when they work. Just like what Ellen Williams said yesterday about, you don't expect all of them to work. She showed, the fact is that most of the ideas don't make it to a commercial stage, but the ones that can, you want to push forward. And so that we have a goal of partnering with industry and also with government and not-for-profit to reach these solutions. And then finally, this is a very audacious goal, to become the center that governments turn to for information and advice. So what are we doing to reach those goals? So I have a slide that sort of shows you the strategic programs we've developed to reach those goals. So remember, the first goal had to do with intellectual community. So we have a highlight seminar series as part of that, to bring in world leaders in various areas to give talks. And we've had over 40 speakers since 2011. I'm going to show you the highlights of the highlight seminar series on the next slide. As I said, we have research innovation funds that we use to essentially encourage new collaborations, not old ones. We want to keep trying to get to new solutions, to new ideas, and so we bring together faculty teams, and we've funded almost 30 faculty teams since 2011, about 40 undergraduate internships, 7 graduate fellowships. This is a way, again, that builds the research activity of the center. In terms of education, in addition to developing new courses, we have 2 what we call certificate programs. They're multidisciplinary minors. So students here do a deep dive into a discipline for their major or concentration, as it's called here, and then they have the opportunity to take a series of courses and that may lead to a senior thesis or an independent work project that then they write up. I'm going to show you some examples of that. And we have 2 of them. We have one that is aimed at, it's a very technical certificate, the Program in Sustainable Energy. The technical certificate for essentially science and engineering students. And I'm very happy about that. I think this is important. They can take courses on solar energy. They can take courses on wind energy, nuclear energy. But what I'm actually even more excited about is a program we started joint with the Keller Center for Innovation in Engineering Education a few years ago that's aimed at the humanities and social science students. Because here at Princeton, we have, if you look at the history of Princeton, including Gary Andlinger, who, by the way, majored in economics, you have a group of people who are incredibly talented and who end up going to become the leaders in the world, the last 3 Supreme Court justices, for example. And so what you realize from that is we have an opportunity, and I would argue an obligation, to provide them with a chance to learn about the issues associated with energy and its impact on the environment, its impact on society, how society makes choices about the energy landscape that exists. And so while we don't exclude, we don't discriminate, the science and engineering students can take that certificate. What I find is tremendously value added is the fact that we are reaching out to the humanities and social science students in this way. The program in sustainable energy is, of course, very important, and I should say it's directed by Yiguang Zhu, professor in mechanical and aerospace engineering. But I do feel that most scientists and engineers, if they wanted to go learn about energy, they could, and they would. But the humanities and social science students, to reach out to them, I think is something quite unique. And then we have this industrial affiliates program that was launched in 2011. Lin Lu led the launch of this. And essentially the idea is to promote collaboration and technology transfer out into industry. And right now our partners, our major partners are ExxonMobil and 2 utility companies, the largest utility in New Jersey, PSEG, and Southern Company, another very large utility, and then 2 other small companies are current members. And then finally, so this is the partnering with industry part, this is the education part, this is the research part, the intellectual community, and then finally I said we wanted to become a center where that government can turn to for information and advice. And one way to do that is to think about how we can provide good information to decision makers. And in fact, this idea came originally from a visit that I took to Capitol Hill early on in my directorship tenure. And I asked staffers there, what could we do as a center that would be helpful to them? And what they said was, we need good information. What a surprise. And so, but they said, we would like to have that information in as brief form as possible. And so, because they're flooded with information. So out of that, in a discussion that I had with Robert Sokolow, who is right here, we came up with the idea, and Rob said, this shouldn't just be for Capitol Hill, it should be for any interested person, any interested layperson. And so out of that arose this project that I dubbed the Energy Technology Distillates. You'll have an opportunity tomorrow, the capstone part of the program, to hear from Rob and some of the students who've been involved, the graduate students that have been involved on a panel about the latest distillate. So what are these? It's, again, public education on emerging energy technologies. The distillate part is we're distilling down to the essence the key ideas associated with emerging energy technologies. And the ideas are not just the technical ideas. They include an economic analysis, a policy assessment, environmental impact, and other nuances associated with any particular one of these distillates. We've produced one each year for the last 3 years. The first one was on grid scale storage, whether or not it will enable renewable energy to really take hold. The second one was on nuclear energy. And I should say something, somehow in some sense, slightly by accident, these have been timely at the time they've come out. So the grid scale storage one came out right as the new regulations associated with mercury came out on power plants. It was really interesting. And then the small modular nuclear reactors one that came out last year came out just at the time of the Iran negotiations. And this one that was just released on magnetic confinement fusion is coming out right as the U.S. is thinking about their commitment to ITER, the very large project in France. So we're hopeful that this kind of information that is meant to place us as an honest broker. We're not advocating for any particular solution. We're just saying, here's the state of the technology, here are the challenges, that can be useful for decision makers going forward. Okay, I said I wanted to talk about the highlight seminar, so this is kind of a palindrome highlight seminar series highlights. I just selected a few of my favorite talks from the last 5 years, and they're in different areas. So we had some just fabulous talks on solar energy and wind energy and biofuels, and these are some of the highlights. I'm delighted that Dave Eaglesham is here somewhere. Where are you, Dave? Yes, yeah. He gave a fantastic talk in the first year. He was the CTO of First Solar. Anyway, there's really terrific talks in that area. Carbon capture and storage, new ideas for carbon capture materials. Excellent talks on batteries and power electronics. I think Michelle Addington is here too somewhere. She gave a beautiful talk on sustainable architecture design. And we also had some really great talks on energy policy and economics. Richard Kaufman will be here tomorrow to tell us about his work at the state level on energy financing. Okay, so that gives you an idea of how we bring in people from the outside. I told you that we are working on this portfolio of solutions. Well, that portfolio of solutions is laid out. Probably the people in the back can't see this, but there's a whole huge set of areas that people at Princeton are working on. We have a research directory. I encourage you to look at it that has over 100 faculty involved. That's kind of, I like to think about the people in the center as a set of concentric circles. And this is kind of the outside circle of all the people that are doing research that relate to these solutions that we want to get to. And then the question is, well, how do we bring them all together? What's the network? And the network is essentially the core individuals within the center, and that's the leadership team. So there's me, but in particular, I want to give a very special shout out to Jennifer Pacelli, the Associate Director for Administration, because she's really become the heart and soul of making sure that everything, including this beautiful symposium that we have going on, is functioning in a terrific way. And then Paul Chirick is the Associate Director for External Partnerships for eAffiliates. Peter Jaffe, you just met, Associate Director for Research, and Neeraj Jha is the Associate Director for Education. And this leadership team makes sure that all those activities that I just told you about work smoothly in conjunction with our staff, which I'll show you in a moment. The second piece out from that leadership team in the concentric circle, so we went from the large circle to the small circle, and then the next one out, that's the intimately involved group, are jointly appointed faculty, and we have 7 absolutely superb junior faculty that have been appointed. Minji Chen is our latest. He hasn't come yet. He won't be here today. But you are going to hear talks from all 6 of our junior faculty to see what they're doing. And what you can see is that they cover these strategic areas. The strategic areas include biofuels, include control of fusion energy, energy efficient buildings, power electronics, carbon capture and storage and sustainable building materials, especially concrete, and batteries for electric vehicles and grid scale storage, and energy efficient lighting and energy efficient and cheap solar cells. So you're going to have a wonderful display of the research that's going on in the center throughout the next day and a half. And then out from that set of key faculty, so the leadership team, you have the jointly appointed faculty, and then we have a range of people, 35 right now, associated faculty, who represent all the sciences, all the engineering departments, also the policy school, different parts of the policy school, and the School of Architecture, all engaged. And this is the A team of faculty that have spent time helping build the activities of the center in one way or another, have given their time to the center, are really committed to the ideas of the center. And I just want to call out, I'm not going to read all their names, but I wanted to really honor them because without their help, it would not have come to pass, all of the activities of the center. So we also have a group of research scholars that are really world-renowned energy systems analysis group that is now part of the Andlinger Center. They've worked closely with Rob Sokolow over many years as well. And then we've had a series of visitors. We have a visitors program that's brought people ranging from academics, such as Dan Jamar, an environmental engineer, Mike Schwartz, what used to be senior VP of Duke Energy, and he spent time here. Right now, our current visitors include Fabian Wagner, who comes to us from Vienna, from IASA, an applied systems analysis, International Applied Systems Analysis group there. And Mitch Small is from Carnegie Mellon. And Martin Hansen is world-renowned for his work on wind energy technologies. And so we're very fortunate to have that also contribute to the intellectual community. As I said, none of this would happen. The lifeblood of the system really is the staff. And I want to just give a call out to the great staff that we've assembled here in the Andlinger Center. So I see that I'm running over time, but we did start a little late. So but I'm going to stop very soon and just point out that this is just to give you some example of these energy technology and society certificate projects. That these are the undergrads that are doing these projects. They're coming from economics, from history, from computer science, and you see that they range from the history of coal production in the UK. This was actually our first graduate of the program, who then, she's the poster child, Margaret is, in my mind, for what we want to do, because essentially her whole thesis led her, essentially, she mapped out the history of the coal production in the UK and how, because of the visibility of the pollution associated with that, the health effects of that, how that ended up essentially spawning the environmental movement in the UK. And out of that, she was really profoundly affected by this certificate. She went off after graduation and joined an environmental firm. So I love that. There's a whole set of sustainable energy certificate research projects. I don't have time to tell you about it. We have a summer internship program. These are a lot of undergrads working in our laboratories. And so we also have, through the generosity of Paul Mader, a graduate fellowship, and these are the two latest awardees. They just were announced. One working on environmental issues, another working on energy issues. The e-affiliates program I already mentioned. We've had visitors associated with them. Eric Herboltheimer is in the audience, who's spending time with us. And we have events associated with those. I mentioned the distillates project. I'll end by just showing you the building that you've already been in and hopefully seen, but we have really now state-of-the-art equipment and facilities that we hope will be a hub actually for the entire east coast of the United States in many ways. And last but absolutely not least, we have continuity. And the continuity is in the form, I'm going to be stepping down as the director, but I'm delighted to announce that Lynn Liu, who was the deputy director for 4 years in the Andlinger Center, is going to become the next director of the Andlinger Center as of July 1. And I know that she's going to do a fantastic job. And with that, my last slide is that none of this would have happened without the extraordinary generosity of many people, both private and also in the industrial sphere. And I want to leave this up just to recognize them. It's allowed us to do the work we're doing and to catalyze all the events that you've seen today. Thank you.
Thank you, Emily. We have time for questions.
My question is, in addition to the areas that you've outlined and the hired, are there additional areas that you'd like to go or hires that will be?
Yes. So the question was whether or not we will have, are there other areas that we want to work in, activities and other hires? And so, in fact, we do have offers out to a couple of people. One who is working in the carbon capture area, actually, I would say carbon sequestration area, and another who is working on the behavior side of energy and environment. And we are waiting to hear whether they will join us. I'm not going to say who they are. But, you know, we have absolutely intentions to broaden the faculty even further in terms of reaching out to other parts of the sciences and to the social sciences, absolutely. And the other thing that I know Lynn is very interested in, and we had done early on a strategic planning exercise of what we wanted to accomplish in the center. And we deliberately deferred one aspect, which Lynn is absolutely poised. She's the right person to move forward on this. And that is to be reaching out internationally. We did have people coming from other centers to visit who wanted to establish partnerships, and I deliberately put them off because I wanted to make sure that we built our infrastructure and built our infrastructure both in terms of bricks and mortar, but also in terms of people and activities. But now we really are poised. We've got all of these activities going. We've got all these great people, great infrastructure. It's the right moment to now come back and say, we can be a great partner externally and internationally, I mean, in particular, because we do have these external partnerships with industry right now. And so Lynn, I know, is very interested in doing that. So I think that's going to be a strong new direction, right? Yeah. Yes?
Having once worked in research with ExxonMobil, what is the nature of ExxonMobil's support?
So the nature of ExxonMobil's support, ExxonMobil has been spent quite a bit of time figuring out how they wanted to interact with industry in the area of energy. And they picked several different universities, first MIT, then us, to start to work with in a way in which what they do is they provide, I could let them say, but what I can say is I think that much of what they want us to do is really just do exploratory research. It's great, okay, because they are offering up opportunities, very early stage research, to look at different aspects of this energy portfolio. It is absolutely the case, and ExxonMobil understands this, that while they enable our quality of life by keeping the lights on, et cetera, and allowing us to have transportation, that someday we all need to be transitioning off, and they want to position themselves to be that energy provider through a lot of different technologies. So they invest internally, they do great research internally, but they also come to us to do the kind of research that they don't have internally, because we have different expertise. Yes?
Tell me about the distillates. Do you have a program whereby you present that to policymakers, say on Capitol Hill or in other state houses? Do you have a system set up for that?
So you have hit on something very important. We've talked about it. We haven't done it yet. I think that is something that we want to do, is to have the opportunity. You know, there's a lot of interesting dynamic as to when you do that and how to make that happen. But we would absolutely be open to doing that at the state level and the federal level. Right now, what we do is we send those documents out to every member of Congress. We send them, out to a variety of different constituencies, but we're looking to amplify how we get the information out. And so it's something we would like to do, is absolutely organize those kinds of events. Yeah. And you'll hear more about that tomorrow. Yes.
May I remind people that are asking questions to please state your name and affiliation?
Elie Bouzet, Civil and Environmental Engineering. I always had the same vision that in the long term fusion will be providing all of our energy, but I wonder now, by the time this point is reached, whether fusion is actually going to be able to compete economically. Is it going to be a very expensive source compared to where solar and wind and other sources will be at that time?
Elliot's a great question, and I urge you to go read the distillate that was just released. But what I can tell you is that there's an economics article in that distillate, and the answer is that it's very uncertain what the cost is going to be. The current assumption is to imagine that it has to compete at least at the level of nuclear fission, okay? And so otherwise it's not going to come online. And so if you make that cost estimate, what you can say is, you can say there has been a study, which is discussed in the distillate, in the long, I'll say one thing about the distillate. The distillate has an executive summary. That's what I had shown you. I'd shown you the front of it for fusion energy. And that's a 4-page summary. But behind that is a suite of short articles. And you can go then, it's all online, by the way, right there. And you can go click, if all you want to know about is what's known about the economics, you can go read the economics article. And in that economics article it's based on a study that was done to sort of figure out at least what the fraction of costs are going to be. And one of the main costs associated with ongoing fusion power will be the replacement of the innards, if you like, of the reactor vessel because of the bombardment of neutrons, okay, and potentially helium nuclei. Okay, so because of that, that's something which is an ongoing cost. But there's a whole, it's a fascinating document, this one, and you'll hear more about that tomorrow.
Time for one last question. Emily, maybe, do you want to expand a little bit? The university is really a little town, and with the center we have a partnership with the university as a lab. Do you want to? I think that's... Okay, yeah, that's a good point. So one other interesting activity that I didn't cover here, I mean, I didn't cover every single activity that we have, and one of the activities that we do have, which I think is quite interesting, is we have a project we call Campus as a Lab. And the idea is that actually it's supported by the Andlinger Center and by the Office of Facilities and the Dean of the College and the Princeton Environmental Institute and several different groups on campus. And the idea is that we have, for example, in fact, I know Ellie, who we just heard from, has been involved, Peter Jaffe's been involved, others, Forrest Meggers, who we'll hear from later, to take the technologies that we are developing in the laboratory and actually deploy them here at Princeton as a way of testing those technologies. So it often involves undergrads too, which is really great, in addition to graduate students. Thank you, Emily.